If there exists a place in the cosmos where time itself slows, edging ever closer to a halt, could that be nature's own time machine? This question lingers at the threshold of human curiosity, teasing the boundaries between physics and philosophy. Such a realm is not the stuff of mere imagination, but resides deep within the enigmatic heart of a black hole, a cosmic abyss, where gravity warps not only space, but time itself. To grasp this concept, one must first understand the profound strangeness of black holes. These are not simply voids or dark patches in the sky. They are regions where matter has collapsed into an infinitely dense point, known as a singularity, surrounded by an event horizon, the invisible boundary beyond which nothing escapes. Approaching this horizon is akin to stepping onto the edge of time's unraveling. Time, as we experience it, flows steadily forward, measured by the ticking of clocks, the rising and setting of suns, and the changing seasons. Yet near a black hole, Einstein's theory of general relativity reveals a startling truth. Gravity is so intense that it warps space-time itself. To an outside observer, a clock falling toward a black hole appears to slow dramatically, ticking ever more slowly as it nears the event horizon. In essence, time dilates, it stretches and elongates until, at the horizon's edge, it seems to freeze altogether. This phenomenon raises a tantalizing possibility. Could this natural distortion of time serve as a form of time travel? Not in the science fiction sense of hopping through eras or rewriting history, but as a window into the deepest reaches of time itself, a way to peer back or linger within moments stretched beyond human comprehension. Imagine standing just outside this cosmic boundary where seconds can stretch into years. The universe beyond rushes forward at its usual pace, but here time lingers like molasses in winter. Could such a place be called a natural chronometer, one that allows glimpses into epochs long past or future? Might ancient civilizations have understood this cosmic truth before us? Could remnants of their knowledge be encoded in myths or lost monuments, whispers from an era erased by the relentless march of deep time? Deep time, the vast expanse stretching billions of years into Earth's past and future, is difficult for our minds to grasp. Human history flickers briefly against this backdrop. Our existence is but a fleeting breath in geological terms. Yet black holes remind us that time is not absolute. It bends and flexes under cosmic forces far beyond our daily experience. This idea resonates deeply when considering Earth's own timeline. Our planet has witnessed cataclysms and epochs that would dwarf any human lifespan: ice ages grinding continents under glaciers, volcanic eruptions reshaping landscapes overnight in geological terms, mass extinctions erasing entire branches of life, and yet time marched on. The rock strata beneath our feet are pages in Earth's diary. Though many chapters have been lost or overwritten by relentless erosion and tectonic shifts, could black holes offer a metaphor or even a literal gateway to understanding these lost chapters? If time near them slows so profoundly, then in some sense they encapsulate moments frozen out of ordinary flow, a paradoxical preservation amid destruction. While matter crossing the event horizon disappears from our view forever, the stretching of time outside suggests echoes linger longer than we might imagine. Scientific inquiry into these realms continues to push boundaries. Observatories scan for gravitational waves, ripples in space-time caused by colliding black holes, offering glimpses into events billions of light years away and millions or billions of years ago. Such observations hint at layers of cosmic history encoded in space-time itself. Yet despite these advances, black holes remain shrouded in mystery and paradox. The singularity defies current physics. Theories collapse under infinite densities and broken laws. Some propose that information swallowed by black holes might be preserved somehow, a holographic imprint on their surfaces, challenging notions about loss and permanence. From a philosophical standpoint, this invites reflection on time's nature. Is it linear or cyclical? Is it a river flowing inexorably forward, or an ocean with hidden depths where currents swirl backward? Black holes suggest that our intuitive experience is limited, a mere fragment within far grander temporal architectures. In this light, pondering whether black holes act as natural time machines becomes more than scientific speculation. It becomes an exploration into humanity's place within an immense cosmos where time itself is fluid and mutable. The slow dance near these cosmic abysses invites us to reconsider how we measure existence, not just by clocks or calendars, but by understanding how deep time stretches across space and matter. Ultimately, contemplating these cosmic enigmas connects us with something ancient and vast, a reminder that our brief flicker upon Earth is part of an unfolding story written across stars and space-time. Black holes stand as both graveyards and archives, consuming light and matter while preserving secrets about the universe's deepest workings. In their shadowy presence, we glimpse how fragile our notions of past and future truly are, and how much remains undiscovered. Beyond the horizon, where time itself almost stops, when a colossal star reaches the twilight of its existence, it embarks on a journey that transcends mere death. The once radiant beacon of light and energy, which for millions or even billions of years had burned with unfathomable intensity, now faces an inevitable collapse, a final act that reshapes the very fabric of reality. In this cataclysmic finale, the star's core succumbs to the relentless pull of gravity, imploding inward until it compresses into a point of infinite density. This is the genesis of a black hole, a cosmic enigma that stands as both the remnant and the testament to stellar death. This transformation is not merely a physical event, but a profound revelation about the nature of time itself. The black hole emerges from the ashes of destruction as a paradoxical monument. It is at once an end and a beginning, a place where conventional understanding falters and new possibilities arise. To appreciate this, one must consider what occurs as the star's core collapses. Within the star's heart, nuclear fusion had long battled gravity's ceaseless squeeze, generating outward pressure that held the star aloft. But when fuel is exhausted, fusion halts, and gravity seizes control unopposed. The core implodes, shrinking ever smaller under its own weight. As it contracts beyond any known scale, matter is compressed into an infinitesimal point known as a singularity, where density becomes infinite, and the known laws of physics break down. Surrounding this singularity is the event horizon, an invisible boundary marking the point of no return. Herein lies one of nature's most profound secrets. The black hole is not merely an object in space, but a doorway into altered dimensions of time and existence. Its formation reveals how deeply intertwined space and time are, how they fold and warp under extreme conditions. The collapse to infinite density warps space-time so severely that time itself slows dramatically near this abyss. From afar, observers witness something extraordinary. As matter spirals inward toward the event horizon, its fall appears to slow inexorably, frozen in time by gravitational distortion. Clocks near this boundary tick more slowly relative to those far away, a phenomenon predicted by Einstein's theory of general relativity and confirmed through astrophysical observations. In this sense, the black hole becomes a natural archive of moments stretched beyond normal comprehension. But what does it mean for time to be stretched or slowed? It suggests that time is not an absolute river flowing uniformly, but a pliable medium shaped by gravity and mass. Near a black hole's event horizon, seconds may extend into eons. From an outside perspective, moments linger as if caught in amber. This defies everyday experience where time marches relentlessly forward at a steady pace. The birth of a black hole thus uncovers an essential truth. Time can be warped to such extremes that its very nature becomes fluid and enigmatic. The singularity at its core embodies this mystery, an infinitesimal point where space collapses entirely and time loses meaning as we understand it. It is here that our current physics falters. Infinity resists comprehension. Yet these cosmic abysses do more than challenge scientific theory. They inspire deep philosophical reflection about existence itself. Black holes stand as eternal remnants of stellar death, yet paradoxically preserve echoes of moments suspended beyond ordinary flow. They are graveyards where matter disappears, but also archives where time dilates infinitely. This duality invites us to reconsider our place in deep time, the vast temporal expanse encompassing billions of years before and after human history. Earth's own timeline feels fleeting against such cosmic scales. Our planet has endured cataclysms far exceeding human lifespans and civilizations erased by epochs long past. Could black holes be metaphors or perhaps literal keys to understanding these lost chapters? If time near them stretches beyond measure, then they hold fragments of cosmic history frozen outside normal progression. While matter crossing their horizons vanishes from sight forever, the gravitational lensing and time dilation surrounding them suggest lingering traces persist in subtle ways. Moreover, black holes remind us that destruction is inseparable from creation in the universe's grand narrative. The death throes of massive stars give rise to these enigmatic objects that shape galaxies and influence cosmic evolution profoundly. Their immense gravitational pull sculpts space-time itself, orchestrating celestial dances that ripple across billions of light years. As scientific inquiry advances, with observatories detecting gravitational waves emitted by colliding black holes, we gain glimpses into events occurring eons ago at unimaginable distances. These ripples carry encoded stories about cosmic origins and transformations written in space-time's fabric. Still, much remains unknown. The singularity resists integration into quantum mechanics. Information paradoxes challenge assumptions about loss and preservation. Hypotheses about holographic principles hint at deeper layers yet uncovered. In contemplating black holes as remnants born from stellar death, yet gateways to temporal mysteries, one confronts profound questions. Is time linear or cyclical? Is reality fixed or malleable? Does deep time conceal civilizations long erased beneath layers of rock and memory? Through these reflections emerges a humbling perspective. Our brief existence on Earth is but a flicker amid vast cosmic rhythms, where time bends unpredictably under forces beyond human scale. Black holes stand sentinel over these mysteries, both consuming light and matter while preserving secrets about existence's deepest nature. In their shadowy presence lies a reminder. Every ending births new enigmas. Every collapse reveals hidden architectures within space-time. Every moment holds echoes, stretching beyond immediate perception. Thus, when a giant star dies, collapsing into infinite density, creating a black hole, the universe unveils not just an endpoint, but an invitation to peer deeper into time's hidden corridors, to embrace uncertainty with wonder, and to recognize that within destruction lies profound insight into reality's timeless dance. The black hole remains one of nature's most poetic paradoxes, a monument forged from stellar demise, yet enduring as a symbol of infinite possibility within deep time's vast ocean. It teaches us humility before cosmos's grandeur and encourages ceaseless curiosity about what lies beyond horizons where even time itself almost ceases to be. 3. The event horizon, the point of no return. In the vast theater of the cosmos, there exists a boundary unlike any other, a threshold where the familiar laws of physics falter and time itself seems to unravel. This boundary is known as the event horizon, the enigmatic frontier encircling a black hole where even light, the swiftest traveler in the universe, finds no escape. It is a line drawn in the fabric of space-time, a point of no return that beckons with both awe and dread. To an observer far from the black hole's grasp, the event horizon appears as a shimmering veil, a luminous ring sculpted by gravity's relentless pull on passing photons. Yet this glowing facade masks an unsettling truth. Cross this boundary, and all paths lead inexorably inward, swallowed by a darkness from which no signal can ever emerge. Here, space curves so steeply that outward journeys become impossible. Here, time slows to a crawl, stretching moments into eternity. What does it mean for time to slow near this cosmic precipice? Imagine standing at the edge of a vast waterfall, where water cascades with unstoppable force. Now replace water with time itself, flowing steadily across the universe, and envision it thickening as it nears this abyss, thickening until it becomes almost solid. Clocks placed just outside the event horizon tick ever more slowly compared to those in distant space, their hands crawling forward like weary travelers trudging through molasses. This phenomenon is not mere speculation, but a consequence of Einstein's general relativity, a theory that reshaped our understanding of gravity not as a force, but as curvature in space-time. Near massive bodies like black holes, gravity warps this continuum so intensely that time dilates dramatically. To distant eyes, an object falling toward the event horizon appears frozen, suspended in an eternal moment just before vanishing from sight. Yet from the perspective of the falling object itself, time flows normally. It crosses the event horizon without fanfare or warning, unaware that it has passed beyond humanity's reach. This duality, the external observer's frozen tableau contrasted with the infalling traveler's seamless passage, exemplifies the profound strangeness woven into black holes' nature. The event horizon thus embodies a paradox. It is both a boundary and a bridge, a veil separating observable reality from realms hidden deep within gravity's grasp. It challenges our concepts of causality and temporality, forcing us to question what it means for events to be in the past or inaccessible. Beyond this boundary lies not emptiness, but an inscrutable domain where known physics collapses and new laws await discovery. For all its mystery, the event horizon offers tantalizing possibilities for physics and philosophy alike. Could it be a natural laboratory for exploring quantum gravity? the elusive theory uniting quantum mechanics with general relativity? Might information swallowed by black holes be encoded upon their horizons themselves, preserving cosmic memory in ways yet to be understood? These questions fuel ongoing research and ignite imagination. Moreover, contemplating the event horizon invites reflection on humanity's place within deep time and space. Our brief lives unfold against an ancient universe where black holes silently sculpt galaxies and weave space-time's intricate tapestry. The event horizon stands as a metaphor for limits. Limits of knowledge, perception, and existence itself, reminding us that some mysteries may forever lie beyond reach. Yet within these boundaries also lies profound beauty, a cosmic threshold where time dilates into infinity, where moments stretch like shadows lengthening at dusk, where light teeters. On the edge between escape and oblivion, the event horizon is not merely an end, but a beginning, an invitation to peer into nature's deepest secrets and embrace uncertainty with wonder. In this light, the event horizon transcends its scientific definition to become a symbol of transition, transformation, and transcendence. It marks where our understanding meets its limits and where curiosity propels us forward into unknown realms. As we gaze toward these dark frontiers, we glimpse not only black holes but reflections of our own quest to fathom time's depths and find meaning amid cosmic vastness. Ultimately, the event horizon teaches humility before nature's grandeur and resilience in face of mystery. It whispers that while some doors close irrevocably, others open onto vistas beyond imagination, where time slows yet life's enigma endures eternal. Thus stands the event horizon, a silent sentinel guarding secrets at space-time's edge, a boundary where light dies but questions ignite, where physics falters yet dreams persist, where deep time reveals both its limits and its boundless promise. For the stretching of time, a cosmic illusion and reality, at the precipice of a black hole's event horizon, time does not merely slow, it becomes stretched, elongated, and distorted beyond ordinary human reckoning. This phenomenon, known as gravitational time dilation, is one of the most profound consequences of Einstein's general relativity. It reveals that time is not an immutable, universal constant, flowing uniformly for all observers, but a flexible dimension, intimately woven with space and responsive to gravity's immense power. To envision this, imagine the hands of a clock placed just outside the event horizon. For an observer far away in the calm regions of space, those hands seem to crawl ever more slowly, ticking with agonizing lethargy as they approach the black hole's boundary. A single second near that edge might stretch to hours, days, or even years for the distant watcher. It is as if time itself becomes viscous, a thick syrup slowing every movement to a near halt. This effect is not metaphorical, but real and measurable. The closer one gets to the black hole's event horizon, the more extreme this dilation becomes. In principle, at the very edge, the threshold where escape velocity equals the speed of light, time appears to freeze altogether. From an external vantage point, what this means is staggering. A process or event unfolding near that boundary could be witnessed by a distant observer as if trapped in a frozen tableau, forever suspended in an eternal moment. Yet from the perspective of someone or something falling toward this abyss, time ticks normally. Their own experience remains uninterrupted. Seconds pass, as seconds do elsewhere. They cross the event horizon without sensing any abrupt change in their temporal flow. This paradoxical duality underscores how time is fundamentally relative, its passage contingent on one's position within space-time's warped geometry. The implications ripple far beyond theoretical physics. They invite us to rethink our very notion of temporality and existence. If time can stretch so drastically under gravity's influence, then what we perceive as now becomes a fragile construct, a localized experience bounded by our place in the cosmos. Near a black hole now dilates into forever, moments expand into epochs. This stretching of time challenges our understanding of cause and effect as well. Events occurring near the event horizon may appear delayed or drawn out when observed from afar. Now! Signals emitted take longer to reach distant observers. Light itself becomes redshifted, its frequency lowered by gravitational pull until it fades into darkness. It is a realm where temporal sequences warp and intertwine, a liminal zone where past and future blur. In contemplating such distortion, one cannot help but draw parallels to Earth's own deep history, a history written in layers of rock and fossil but often obscured by erosion and tectonic upheaval. Just as geological processes compress and stretch eons into strata visible beneath our feet, So too does gravity compress and stretch time near these cosmic abysses. Both remind us that time is not merely a backdrop, but an active participant in shaping reality. The metaphor extends further when considering ancient civilizations long vanished beneath millennia's relentless tide. Could their stories be likened to signals caught in gravitational redshift, faint echoes distorted and stretched until barely recognizable? Might some lost knowledge lie suspended in temporal folds beyond ordinary reach? The analogy is speculative, yet evocative. Black holes hold moments suspended beyond normal flow. Earth holds histories buried beneath layers of forgotten ages. Moreover, gravitational time dilation near black holes invites philosophical reflection on impermanence and eternity. What does it mean for something to be frozen at the edge of time while the universe marches onward? Is this cosmic stasis a form of preservation or entrapment? Does it hint at timelessness beyond mortal comprehension, or merely an illusion born from perspective? Scientists continue probing these questions through observation and theory. The detection of gravitational waves, ripples propagating through spacetime from merging black holes, offers new windows into events billions of years old, their signals stretched across vast distances and epochs before reaching us. These waves carry encoded histories, distorted yet decipherable through careful study. At the frontier of research lies the quest to reconcile general relativity with quantum mechanics, to understand how information behaves when swallowed by black holes and whether it truly vanishes or endures in transformed states. Concepts like holographic principles suggest that information about matter falling in may be preserved on the event horizon itself, a cosmic ledger inscribed at the boundary where time dilates infinitely. Such ideas challenge classical notions about loss and permanence, urging us to reconsider what it means for something to exist in time. If moments can be stretched indefinitely at gravitational thresholds, then perhaps history itself is layered, some chapters accessible within ordinary flow, others encoded in slowed or frozen domains beyond direct perception. This interplay between physics and philosophy illuminates humanity's place within deep time, the vast expanse encompassing Earth's ancient past and cosmic future alike. Our brief lives flicker against epochs spanning billions of years. Our memories fade while stars are born and die. Yet within black holes' grasp, time itself unfolds differently, a reminder that existence transcends linear progression. In this light, black holes emerge not only as destructive forces, but also as natural chronometers, cosmic devices that stretch moments into eternity and reveal hidden facets of temporality. They invite us to ponder whether time's passage is absolute or contingent, whether history is fixed or fluid, whether reality contains layers unseen beneath familiar flow. Ultimately, confronting the stretching of time near black holes evokes awe mingled with humility, a recognition that our intuitive experience captures only slivers of a grander cosmic dance where space bends and time warps under gravity's sway. It inspires wonder at nature's capacity for paradox, where destruction births preservation, where endings unfold into beginnings, where moments may linger forever on horizons beyond sight. As we contemplate these profound truths from afar, our minds reaching toward realms where seconds become years, we glimpse a universe both majestic and mysterious, one in which deep time stretches like an infinite ocean shaped by forces inscrutable yet beautiful, one where black holes stand sentinel over thresholds not only of space but of time itself. In their silent presence lies an invitation to explore further, to embrace uncertainty with reverence, to recognize that within cosmic depths lie secrets about existence's essence awaiting discovery by minds willing to journey beyond horizons where even time almost stands still. 5. The double observation effect. Time's divergent streams. At the heart of the black hole's enigma lies a profound paradox, a duality of experience that defies ordinary intuition and challenges the very fabric of reality. Imagine for a moment a traveler venturing toward the abyss, crossing the event horizon and descending into realms where space-time itself contorts beyond recognition. For this traveler, time flows with all the familiar cadence of seconds, minutes, and hours. Their heartbeat pulses steadily, and moments pass unremarkably as they journey deeper into the unknown. Yet to an observer stationed far from this cosmic maelstrom, watching through the lens of distant light years, the traveler's descent appears frozen, a ghostly figure eternally suspended at the precipice of oblivion. This phenomenon is known as the double observation effect, a striking illustration of time's relativity under extreme gravitational influence. To understand it fully requires stepping beyond our everyday experience and embracing a universe where time does not tick uniformly but bends and stretches in response to gravity's profound grip. From the vantage point outside the black hole, as an object approaches the event horizon, its image slows, colors redden, and movements become lethargic. This redshift caused by gravitational effects stretching wavelengths of light renders the falling matter dimmer and slower until it seems to hang motionless on the brink of disappearance. In essence, to this distant watcher, time for the traveler appears to slow down infinitely. Yet inside this cosmic paradox, the traveler experiences no such suspension. Their own clocks tick normally, their senses remain intact, seconds unfold as naturally as they do on Earth or anywhere else in space, free from extreme gravity. This divergence arises because time is not universal but local, a property that depends intimately on one's position within space-time's curved geometry. This duality invites profound reflection on what it means to exist within time itself. The traveler crosses into regions where known physics yields no clear answers. While outside observers are left with an image frozen in time, an eternal tableau etched against the backdrop of deep space. The philosophical implications ripple outward like waves in a pond. If two observers witness radically different flows of time for the same event, then time ceases to be a singular dimension but becomes layered, a tapestry woven from multiple temporal threads. Reality splits into perspectives shaped by vantage points in spacetime rather than a single objective flow. This divergence also reframes how we consider causality and history. For those outside, events near the event horizon unfold slowly, stretched over potentially infinite durations. For those inside or falling through, events proceed swiftly toward unknown destinies beyond comprehension. The past and future blur at this boundary. Moments that seem eternal from afar are fleeting internally. The double observation effect echoes themes found throughout Earth's own deep history. The layering of perspectives across epochs, now lost beneath sediment and stone, just as ancient civilizations left traces that appear frozen in archaeological strata yet once thrived dynamically in their own times. So too does time near black holes reveal contrasting realities dependent on observer perspective. Moreover, this phenomenon evokes a humbling awareness of human limitations. Our intuitive sense of time as steady and universal is but a narrow glimpse into a cosmos where temporal flow varies dramatically. Under gravity's influence, the traveler crossing into a black hole moves forward through moments imperceptible to external watchers, their fate sealed within regions where clocks tick differently, or perhaps lose meaning entirely. In contemplating these divergent streams of time, one confronts a broader meditation on existence itself. Are there realms beyond our perception where past, present, and future coexist? Does consciousness traverse these layers differently depending on its position within space-time? Could ancient knowledge like that whispered by myths or encoded in ruins be glimpses into such alternate temporal realities? Scientific inquiry continues to probe these mysteries through observation and theory. Gravitational wave detectors capture echoes from colliding black holes billions of years distant, events whose signals stretch across epochs before reaching earthly instruments. These waves carry imprints shaped by time's malleability near massive gravity wells. Yet despite advances, much remains elusive. The singularity at a black hole's core resists current understanding. Quantum gravity theories strive to reconcile conflicting models. Information paradoxes challenge assumptions about permanence versus loss. Within this unresolved frontier lies an invitation to expand our conception of time beyond linear progression, to imagine it as a dynamic landscape shaped by mass and energy, to recognize that what appears frozen or eternal may be transient from another viewpoint. In this light, black holes stand not merely as destructive voids, but as cosmic mirrors reflecting multiple facets of temporality. They reveal how deeply entwined observer perspective is with realities unfolding, and how fragile our grasp on now truly is. The double observation effect thus becomes more than astrophysical curiosity. It transforms into a metaphor for human experience. Amid deep time, fleeting yet eternal, limited yet expansive, isolated yet connected across unseen dimensions. As humanity gazes upward toward these dark sentinels scattered across galaxies, we confront not only physical phenomena but existential questions woven into space-time's fabric. What does it mean to exist when moments diverge? How do we anchor meaning when time itself fractures? Through these reflections emerges a subtle truth that our brief flicker within cosmic history is part of an intricate dance where time flows in manifold ways, where endings hold beginnings concealed, where every observer inhabits their own temporal horizon, shaped by gravity's silent hand. Thus unfolds the paradox at black hole's edge for those who fall inward. Life proceeds with steady heartbeat and flowing seconds. For those who watch from afar, that life lingers suspended forever, an eternal echo etched upon space-time's fractured surface. 6. The breaking point, space-time's final fracture. If one were to journey ever deeper beyond the event horizon, the threshold, already so alien to human understanding, they would approach what physicists term the singularity, a realm where conventional notions of space and time dissolve entirely. Here lies space-time's breaking point, the ultimate fracture where reality as we know it ceases to function coherently. The singularity embodies extremes beyond imagination, infinite density packed into zero volume, gravitational forces so immense they crush all structure, curvature so severe that paths through space loop unpredictably, causality itself may unravel. In confronting this concept, one must embrace both awe and humility. The singularity is not merely a point in space, but a boundary where known physics collapses, where equations diverge toward infinity and predictive power fails utterly. It marks the limit of human knowledge, the horizon where theory surrenders to mystery and perhaps signals realms governed by laws, yet undiscovered or unknowable altogether. Philosophically, the breaking point challenges fundamental assumptions about existence. If space and time vanish or transform at singularities, then what anchors reality? What happens to information swallowed by these cosmic abysses? Does anything persist beyond? Some modern theories propose radical ideas, that singularities may be gateways to other universes or dimensions, that information is preserved holographically on event, horizons rather than destroyed, that quantum effects smooth infinities into finite structures unknown today. Yet despite these hypotheses, the singularity remains an emblem of uncertainty, a reminder that nature holds secrets surpassing even our most refined mathematics. In contemplating this ultimate boundary within deep time's vast ocean, one encounters paradoxes resonant with Earth's own buried histories, civilizations vanished without trace beneath layers of geological upheaval, epochs erased by cataclysms whose causes elude memory. Just as singularities represent final frontiers in physics, so too do lost civilizations symbolize thresholds and cultural memory points beyond which understanding fragments or disappears entirely. Both speak to fragility amid vastness, fragile existence pressed against overwhelming forces shaping cosmos and planet alike, transient narratives folded into grand tapestries spanning eons. The breaking point thus serves as metaphor and mirror, a symbol of endings imbued with possibility, closure intertwined with transformation. It invites us to reflect on mortality, not only personal but cosmic, and on how knowledge persists or fades within unyielding flows of deep time. This contemplation carries profound emotional weight, wonder tinged with melancholy, curiosity mingled with reverence for mysteries beyond reach, yet it also inspires resilience. The drive to explore despite limits, to seek patterns amid chaos, to find meaning amid uncertainty. In this spirit, black holes and their singularities beckon us forward into realms where physics meets philosophy, where existence confronts oblivion, yet hints at transcendence. They teach us that every fracture conceals potential, that even at space-time's breaking point lies invitation to imagine new realities beyond horizons visible now only through glimpses cast by science and imagination combined. Thus concludes this chapter in humanity's quest through deep time, a journey tracing how black holes stretch moments into eternity, freeze travelers in divergent timelines, culminate in singularities shrouded in mystery, and ultimately challenge us to redefine what it means to exist within cosmos, vast beyond measure. In facing these enigmas, the double observation effect and space-time's final fracture, we glimpse not only physics' limits, but also echoes of our own ephemeral place amid stars, small yet seeking significance, transient yet dreaming infinity. 7. The time bridge, black holes as gateways through reality. In the cosmic theater, where stars live and die in spectacular cycles, black holes emerge not only as endpoints, but as profound distortions of the very fabric of existence. They are not merely pits of darkness devouring light and matter. They are crucibles where space and time intertwine in ways that challenge human intuition, and invite us to rethink the architecture of reality itself. Among the most tantalizing implications of this entanglement is the notion that black holes might serve as bridges across different realms of time, natural time machines that connect disparate epochs and perhaps even alternate realities. To understand this possibility, one must first appreciate that black holes do more than warp space. They fundamentally alter time's flow. As previously explored, gravitational time dilation near a black hole's event horizon slows time dramatically relative to distant observers. But beyond this dilation lies a deeper, more enigmatic feature: the potential for black holes to act as conduits, linking separate regions of space-time. These hypothetical pathways, often referred to as wormholes or Einstein-Rosen bridges, suggest that black holes could provide shortcuts through the universe's vast expanse, compressing immense distances and durations into traversable corridors. Yet this concept transcends mere spatial shortcuts. If such bridges exist, they might also connect different moments in time, offering passage not just across space, but through temporal dimensions. Imagine a portal where one could step from one era to another, bypassing the relentless forward march of conventional time. This idea challenges our deepest assumptions about causality and linear progression, hinting at a cosmos where past, present, and future may coexist in a complex web rather than a single thread. The science behind these speculative corridors stems from solutions to Einstein's field equations that permit non-trivial topologies, geometric structures where space-time folds back upon itself. While classical black holes are characterized by event horizons beyond which escape is impossible, certain theoretical models propose traversable wormholes stabilized by exotic matter with negative energy density. Such matter would counteract gravitational collapse, keeping these passages open long enough for information, or even travelers, to pass through. Though no direct evidence for traversable wormholes exists today, their mathematical plausibility invites profound reflection on what black holes represent beyond destruction. They become not only cosmic graveyards, but also potential archives or gateways, portals, preserving fragments of reality otherwise lost to entropy and oblivion. This notion resonates with the idea of black holes as natural chronometers, places where time stretches so vastly that moments accumulate like sediment layers in Earth's geological record. Here, epochs might be preserved or accessed in ways inaccessible elsewhere. If so, black holes could hold keys to understanding deep time's hidden corridors, the epochs erased from Earth's surface by erosion or buried beneath tectonic upheaval. Philosophically, considering black holes as bridges between times evokes a humbling sense of smallness amid vast cosmic cycles. Human history flickers briefly compared to geological eras or cosmic epochs, yet within these enigmatic objects lie possibilities for traversing dimensions beyond ordinary experience. They embody paradoxes, endings that are beginnings, destruction entwined with preservation, isolation coupled with connection. Furthermore, contemplating such temporal bridges challenges our conception of causality. If passage through a black hole's interior could lead one to different points in space-time, past or future, it raises questions about free will, determinism, and the nature of history itself. Could actions taken through such portals alter outcomes? Or is the universe's timeline fixed and self-consistent, despite apparent loops? These inquiries border on metaphysics, but remain grounded in physics' frontier. From an observational standpoint, indirect clues hint at these possibilities without confirmation. The study of quantum gravity, a framework uniting general relativity with quantum mechanics, suggests space-time at microscopic scales may be far more intricate than classical smoothness implies. Quantum fluctuations might generate transient wormholes or entangled connections between distant points in space-time, echoing ideas proposed by holographic principles and entanglement theories. Moreover, the detection of gravitational waves from merging black holes opens new windows into their internal dynamics and potential connections. These ripples carry encoded information about spacetime's curvature during extreme events, possibly revealing subtle signatures consistent with non-trivial topologies or exotic phenomena within event horizons. Yet these frontiers remain shrouded in mystery. The singularity, the heart of a black hole, defies current understanding. It is a realm where known physics breaks down and speculative theories multiply without decisive empirical guidance. Whether wormholes exist as stable passages or remain mathematical curiosities depends on advances yet to come in theory and observation. Still, even as hypotheses await validation, pondering black holes as temporal bridges enriches our existential perspective. It situates humanity within an immense cosmic tapestry woven from space and time's interlaced threads, a universe where realities, layers may fold upon themselves in ways echoing ancient myths of portals between worlds or times. This vision casts deep time not merely as an endless succession, but as a multi-dimensional landscape shaped by gravity's subtle hand, a realm where moments can stretch into eternities or fold back into beginnings yet unseen. In this context, black holes become symbols of mystery and possibility, dark sentinels guarding secrets about the universe's deepest workings, thresholds where science meets philosophy, places inviting us to transcend ordinary perceptions and glimpse dimensions beyond our temporal confines. Ultimately, embracing this speculative vista demands humility and wonder, acknowledging how little we know while igniting curiosity to explore further. It reminds us that within the cosmos's vast ocean of deep time lie uncharted currents flowing between past and future, that within darkness dwell doorways leading to realms where time itself becomes fluid, that within destruction resides hope for connection across reality's manifold layers. Thus concludes this chapter on black holes as natural time machines, a meditation on their role not only as cosmic abysses but also as bridges linking disparate realms of space and time. In their shadowy embrace lies an invitation to journey beyond horizons visible now only through imagination combined with scientific endeavor, to seek understanding amid paradox, to find meaning amid mystery, and ultimately to recognize our place within a universe where time bends not just around massive bodies, but perhaps through epochs themselves. As we stand on this threshold between knowledge and wonder, we glimpse a cosmos both majestic and enigmatic, one whose depths invite endless exploration into the nature of existence across space and deep time's unfolding tapestry. 8. The harsh obstacles, navigating the perils of temporal dilation near black holes, in contemplating the profound possibility that an advanced civilization might exploit the extreme time dilation near a black hole to effectively travel into the future. One must confront a sobering reality. Such an endeavor would be fraught with immense challenges, physical, technological, and existential. The idea of entering a realm where time stretches so dramatically that minutes outside equate to centuries within is tantalizing. Yet the path to such a frontier is obstructed by relentless cosmic hazards and fundamental limits woven into space-time itself. To understand these obstacles, imagine approaching the event horizon not as a mere point in space, but as a boundary where the very flow of time diverges wildly between inside and outside observers. For a civilization intent on harnessing this phenomenon, the goal would be to linger near this boundary long enough for their subjective experience to unfold slowly while eons pass beyond. In theory, this could grant access to future epochs without waiting lifetimes, a leap forward across deep time. Yet the environment near a black hole is far from hospitable. Gravity here is not gentle but brutal, twisting space and stretching matter in ways that defy survival. The immense tidal forces, differences in gravitational pull over small distances, would subject any structure or organism to crushing stress. These spaghettification effects elongate objects along radial lines toward the singularity while compressing them transversely, an unyielding squeeze that tears apart conventional matter. Moreover, radiation fields surrounding black holes pose lethal threats. As matter accretes and spirals inward, it heats to extraordinary temperatures, emitting torrents of X-rays and gamma rays. These energetic emissions bathe the vicinity in deadly radiation, a harsh glare masking the black hole's darkness. Any attempt to station near the event horizon must contend with this searing environment, necessitating shielding and technologies beyond current human capability. But perhaps most daunting are the paradoxes of causality and information flow near these cosmic abysses. Time dilation implies that signals sent outward from near the horizon are stretched and redshifted, arriving increasingly delayed and weakened. Communication with external observers becomes slow and unreliable. Synchronization of clocks breaks down. The passage of information itself contorts under gravity's grip. In this domain, even notions of cause and effect blur. If an advanced civilization sought to send messages or artifacts forward through this natural time bridge, would those transmissions arrive coherently? Could they influence events in the distant future meaningfully, or would gravitational distortions render them indecipherable? These questions touch on deep puzzles at physics' frontier, the black hole information paradox among them, which remain unresolved. Despite decades of inquiry, beyond physical hazards lie existential dilemmas inherent in such temporal journeys. To step into the future by dwelling near a black hole's event horizon is to accept profound isolation from one's origin. Era separated by temporal gulfs inaccessible to direct return or intervention. Observers would watch civilizations rise and fall in distant galaxies while their own subjective time crawls slowly forward. They become silent witnesses to epochs unfolding like cosmic symphonies beyond reach. This temporal solitude poses philosophical challenges about identity and meaning. What does it mean for a being or society to exist stretched across centuries, observed externally but experienced internally as fleeting moments? How does one reconcile the dissonance between subjective continuity and external change? The gulf between internal perception and external reality widens into chasms as time dilates further. Technological hurdles compound these dilemmas. Constructing habitats or vessels capable of resisting tidal forces requires materials and engineering feats currently beyond. Imagination structures resilient against gravitational gradients, orders of magnitude stronger than Earth's gravity. Power generation must endure extreme conditions. Life support systems must operate reliably amid radiation storms. Navigation demands precise control within warped space-time geometries. Furthermore, sustaining biological life under such conditions raises questions about physiology adapted to altered temporal rhythms and intense gravitational stress. Could organic beings survive prolonged exposure where seconds stretch into years? Would consciousness itself adapt or fracture under such extremes? Alternatively, might digital consciousness or artificial intelligence serve as more viable explorers in these realms, entities capable of withstanding harsh environments and enduring protracted subjective durations? Even assuming solutions to these formidable barriers, the fundamental nature of black holes imposes limits on accessing the future via time dilation alone. While time slows near the event horizon relative to distant observers, crossing beyond leads inexorably toward singularity where known physics fails entirely. The interior is a one-way journey. Escape is impossible once past this threshold. Thus, exploiting gravitational time dilation for temporal travel demands precise positioning just outside this boundary. A. Precarious balance between proximity for maximal dilation and safety from fatal descent. This razor-thin margin underscores another obstacle. Maintaining stable orbits or stationary positions near black holes is inherently unstable due to intense gravitational gradients and perturbations from infalling matter or external forces. Minute deviations can precipitate catastrophic infall or ejection into space at relativistic velocities. The cumulative effect is a cosmic gauntlet where only civilizations of extraordinary sophistication could hope to navigate. Safely entities mastering gravitation manipulation, radiation shielding, materials science, and temporal dynamics at unprecedented levels. Yet despite these barriers, theoretical frameworks offer glimpses of potential pathways forward. Concepts such as hovering just outside event horizons using advanced propulsion, counteracting gravitational pull suggest methods for sustained presence within zones of extreme time dilation. Hypothetical exotic matter with negative energy density might stabilize wormholes connecting different space-time regions, possibly facilitating controlled traversal through temporal corridors without crossing disruptive horizons. Speculative physics also entertains ideas about quantum effects smoothing singularities into finite structures or enabling information retrieval from black hole surfaces via holographic principles, mechanisms that could mitigate some fatal constraints. From a broader perspective, these obstacles highlight deep truths about the universe's architecture. That time's malleability comes intertwined with peril, that profound insights often demand confronting extremes, that mastery over space-time may require transcending current physical paradigms altogether. The notion that an advanced civilization could leverage gravitational time dilation as a form of accelerated future travel thus remains both awe-inspiring and cautionary, a testament to nature's grandeur paired with its unforgiving rigor. In reflecting upon these harsh obstacles, one gains renewed appreciation for humanity's fragile foothold amid deep time's vast ocean, a fleeting spark striving against cosmic tides where seconds may stretch into eternities, yet survival demands resilience amid relentless forces shaping existence itself. Ultimately, grappling with these challenges invites humility before mysteries larger than ourselves and inspires relentless curiosity to explore further horizons where physics meets philosophy, where danger intertwines with discovery, where temporal Dreams beckon amid shadows cast by black holes' inscrutable depths. In this interplay between possibility and peril lies the essence of venturing into deep time, not merely as observers, but as seekers willing to confront darkness in pursuit of understanding life's place within an ever-unfolding cosmic story. 9. Supermassive black holes, a gentler gateway through time. At the very heart of galaxies, including our own Milky Way, lie titanic entities known as supermassive black holes. Unlike their smaller, stellar mass cousins born from collapsing stars, these leviathans boast masses millions to billions of times that of our Sun. Their gravitational influence orchestrates the motion of entire star systems and sculpts the very architecture of galaxies over cosmic epochs. Yet beyond their imposing presence lies a subtlety, a gentler, more forgiving nature in their interaction with time and space, one that beckons as a potentially softer portal through the fabric of deep time. To grasp this contrast, one must first revisit the nature of tidal forces, the relentless stretching and squeezing exerted by gravity's gradient across an object's length. Near smaller black holes, these tidal forces become catastrophically strong at or even outside the event horizon. The gravitational difference between one side of an object and the other intensifies to such extremes that any matter venturing too close is inexorably pulled apart in a process evocatively termed spaghettification. This violent ordeal elongates objects into thin strands, shredding them atom by atom, a fatal fate for any would-be traveler seeking refuge near such cosmic abysses. However, supermassive black holes play by a different rulebook. Their sheer size expands the event horizon to immense proportions, often spanning the scale of our solar system or more. This vastness means that tidal gradients near their horizons are comparatively mild. An object crossing this boundary might not experience immediate destruction. Instead, it could pass through with relative structural integrity intact before encountering more extreme conditions closer to the singularity deep within. This difference arises because tidal force scales inversely with the cube of distance from the black hole's center. For supermassive black holes, the event horizon sits far enough from the singularity that gravitational gradients across human-scale objects are gentle rather than catastrophic. In essence, these gargantuan black holes offer a soft landing zone, a threshold where time dilation remains profound, but physical annihilation is not instantaneous. This insight carries profound implications for speculative journeys into deep time. While the smaller black holes' hostile environments pose near insurmountable barriers to lingering near their horizons, supermassive black holes open a window, albeit narrow and fraught with challenges, where advanced civilizations might feasibly hover or orbit close enough to exploit extreme time dilation without succumbing to immediate destruction. Imagine, then, a hypothetical probe or station carefully positioned just outside such a supermassive black hole's event horizon. There, time would dilate dramatically relative to distant observers. Seconds experienced locally could stretch into centuries or millennia beyond. From this vantage point, one could witness cosmic evolution unfold at an accelerated pace, galaxies forming and dissolving, stars igniting and fading, civilizations rising and falling, all compressed into what seems like moments. Yet even here the perils remain daunting. Radiation from accretion disks, the glowing maelstroms of gas and dust spiraling inward, and relativistic jets blasting outward, inject lethal energy into surrounding space. Maintaining stable orbits in such turbulent environments demands technological mastery far beyond current human reach. Shielding against intense X-rays and gamma rays requires materials resilient to radiation damage and capable of dissipating heat generated by relentless bombardment. Moreover, precise control over positioning is essential. Drift too close risks crossing the event horizon irrevocably. Stray too far diminishes time dilation benefits. Navigational systems must compensate for complex gravitational perturbations caused by infalling matter and interactions with nearby stars or magnetic fields threading through galactic centers. The philosophical dimensions of this scenario are equally compelling. To dwell near a supermassive black hole's horizon is to exist in a liminal state between epochs, caught in a temporal eddy where subjective experience unfolds slowly while external reality accelerates relentlessly forward. It raises questions about identity and continuity. How does consciousness adapt when stretched across centuries compressed into hours? What meaning accrues to memories formed in such temporal crucibles? Does perspective itself shift when one perceives deep time's currents flowing so differently? Furthermore, Supermassive black holes anchor galactic centers not only physically but metaphorically. They symbolize points where cosmic history converges and diverges simultaneously. Their immense mass accumulates matter over eons. Their gravitational pull shapes star formation rates. Their energetic outbursts influence galactic evolution on grand scales. They are both creators and destroyers within deep time's unfolding narrative. Scientific endeavors continue probing these enigmatic giants with ever-increasing precision. Observations from instruments like the Event Horizon Telescope have captured silhouettes, the shadows cast by event horizons, against luminous accretion flows, offering unprecedented glimpses into their structure and behavior. Meanwhile, detection of gravitational waves from mergers involving supermassive black holes promises insights into their growth, histories, and interactions across cosmic epochs. Yet many mysteries endure. What exactly transpires within their cores? Do singularities truly represent points of infinite density? Or do quantum gravitational effects smooth these extremes into new states? Could information swallowed be preserved holographically on horizons spanning light days across? And crucially for our contemplation, might these colossal entities serve as natural gateways enabling traversal or observation across deep temporal divides? While definitive answers elude us for now, pondering supermassive black holes invites us to expand our conception of temporal passage beyond linear progression constrained by everyday scales. They exemplify how scale influences experience, not only spatially but temporally, and how vastness can soften extremes that seem insurmountable at smaller levels. In this light, they emerge as paradoxical portals, simultaneously consuming matter and preserving moments stretched nearly beyond comprehension, embodying destruction while offering possibilities for connection across time's gulf, standing as monoliths, anchoring galaxies while inviting reflections on humanity's fleeting presence within cosmic vastness. To contemplate existence near such titans is to confront profound humility, a recognition that despite technological prowess or intellectual ambition, we remain small players within grand cycles spanning billions of years and uncountable stars. Yet it also inspires awe and curiosity, the drive to explore realms where physics blurs into philosophy, where time becomes fluid, where mysteries beckon beyond horizons visible only through imagination intertwined with science. Ultimately, supermassive black holes remind us that deep time is not merely an abstract concept, but a lived reality shaped by forces both gentle and fierce. That cosmic scale alters experience profoundly, that within darkness lie pathways illuminated by understanding's flickering light. As humanity peers ever deeper into these celestial abysses, we glimpse reflections not only of distant epochs, but also of ourselves, transient sparks seeking meaning amid infinity's ocean, fragile yet resilient voices echoing through space-time's corridors, dreamers poised on thresholds between destruction and transcendence. In embracing this vision, we accept that journeys into deep time may demand confronting perilous frontiers, but also promise revelations illuminating existence's timeless dance beneath stars' eternal gaze. Thus concludes this chapter on supermassive black holes, as soft gateways offering tantalizing possibilities amid harsh realities, as colossal anchors weaving space and time into tapestries rich with wonder, as silent sentinels guarding secrets both ancient and profound within deep time's boundless expanse. In their shadowy embrace lies an invitation to continue exploring beyond limits known today, to seek harmony between knowledge and mystery, to honor our place within a cosmos where time bends gently around giants and where every moment holds echoes reaching toward eternity. 10. Connecting information and the cosmos, a dialogue across deep time. In the vast cosmic expanse, where time itself can stretch and fold under the weight of gravity, a profound question emerges. How might information, our most precious currency of understanding, be preserved, transmitted, or even transformed within these extreme environments? The interplay between black holes and information challenges not only our grasp of physics, but also invites reflection on the nature of knowledge, memory, and existence across deep time. Black holes, especially the supermassive ones anchoring galaxies, are often envisioned as insatiable devourers, swallowing matter and light with relentless appetite. Yet beneath this voracious facade lies a paradox. They may also act as repositories or conduits for information, encoding cosmic histories in ways subtle and profound. This concept reframes black holes from mere cosmic endpoints into active participants in the universe's narrative, a dialogue between matter, energy, and the flow of time. At the heart of this dialogue is the black hole information paradox, a puzzle that has vexed physicists for decades. According to classical interpretations of general relativity, any information carried by matter crossing the event horizon is lost to the universe forever. This notion clashes with quantum mechanics' fundamental tenet that information cannot be destroyed. Reconciling these views has led to groundbreaking ideas suggesting that information might be preserved on the event horizon itself, encoded holographically in two-dimensional surfaces representing three-dimensional realities. Such a holographic principle implies that black holes act not as erasers but as intricate archives, projecting histories onto their boundaries in a cosmic ledger written in light and gravity. This revelation carries immense implications for our understanding of time and memory on a universal scale. If black holes encode information about everything they consume, then they become bridges linking past events with future possibilities, repositories where moments stretched by gravitational time, dilation, linger beyond conventional perception. In this sense, they mirror Earth's geological record where layers of sediment preserve snapshots of epochs long vanished. Yet unlike rock strata fixed in place, black holes' horizons are dynamic tapestries woven from space-time's very fabric. From this perspective, the cosmos itself engages in a continuous conversation, a transmission of signals across vast distances and epochs. Gravitational waves detected by observatories like LIGO and Virgo are ripples in space-time born from cataclysmic mergers involving black holes. These waves carry encoded messages about events billions of years old, their patterns deciphered through meticulous analysis revealing insights into mass, spin, and even the nature of gravity itself. They exemplify how information travels not just through light or particles, but through space-time distortions, whispers echoing from deep time's corridors. Moreover, the notion of information intertwines with speculative ideas about advanced civilizations, harnessing black holes as temporal gateways or data vaults. Could such civilizations encode messages within gravitational waves or manipulate horizons to preserve knowledge beyond their lifetimes? While firmly within the realm of speculation, these ideas provoke reflection on humanity's quest to transcend mortality, not merely biologically, but informationally embedding legacies within the cosmos itself. The philosophical resonance here is profound. Information becomes more than data. It embodies continuity amid change, order amid entropy. It represents a thread weaving together disparate moments into coherent narratives, a testament to existence's persistence despite deep time's vastness and chaos. Black holes stand as enigmatic scribes recording these tales of boundaries where time dilates nearly infinitely. Yet this dialogue between information and black holes also confronts limits, the veil shrouding singularities where known physics dissolves into mystery. What lies beyond remains speculative. New dimensions, quantum gravitational realms, universes nested within universes. Each possibility hints at layers of reality beyond immediate reach, yet accessible through imagination coupled with scientific rigor. And contemplating these mysteries, one confronts humanity's own temporal finitude against cosmic scales where billions of years unfold like pages in an eternal book. Our civilizations rise and fall within fleeting moments, stars ignite and perish across millennia. Yet within black holes' grasp, histories may be preserved indefinitely, moments stretched like amber frozen in space-time's flow. This interplay invites humility and wonder, a recognition that knowledge is both fragile and resilient, ephemeral yet enduring through transformation. It calls us to embrace curiosity, not only about physical phenomena, but about how meaning arises from complexity, how memory survives amid entropy, how existence asserts itself across dimensions of time beyond immediate perception. Ultimately, connecting information with cosmic phenomena like black holes enriches our appreciation for deep time's tapestry, a dynamic mosaic where past and future intertwine, where matter and energy converse across epochs, where understanding emerges from interplay between observation and theory, where human inquiry reaches toward horizons both literal and metaphorical. As we peer deeper into these celestial mysteries, decoding gravitational echoes, mapping event horizons, probing quantum frontiers, we participate in an ongoing dialogue spanning space and time, We become both observers and contributors to a cosmic story written not just in stars, but in fundamental threads binding reality together. In this grand conversation lies hope that despite vast distances and profound enigmas, connection endures. That information flows endlessly across deep time's ocean, bridging past civilizations lost beneath Earth's geological mantle with futures yet to unfold among stars, linking human curiosity with universe's boundless expanse, weaving moments into timeless resonance, echoing through space-time's infinite corridors. Thus concludes this chapter on connecting information in the cosmos, a meditation on how black holes serve not only as gravitational giants shaping galaxies, but as subtle archivists preserving echoes of existence, as bridges inviting reflection on memory's persistence amid deep time, as gateways beckoning us toward deeper understanding of reality's intertwined fabric. In embracing this vision, we acknowledge our place within an immense continuum, small yet significant threads interwoven within. Cosmos' eternal narrative, participants in a timeless dance between matter, energy, space, and time itself. 10. The information paradox. Where does data go when it falls into a black hole? In a grand cosmic theater, black holes occupy a paradoxical role. They are at once destroyers and preservers, erasing matter from the observable universe while simultaneously challenging our deepest assumptions about information's permanence. The question arises, when data, whether the physical configuration of particles, the encoded states of quantum fields, or even the intricate records of civilizations crosses the event horizon, where does it truly go? Does it vanish forever into oblivion? Or is it somehow conserved, woven into the fabric of space-time in ways yet beyond comprehension? This conundrum is famously known as the black hole information paradox. It sits at the crossroads of quantum mechanics and general relativity, two pillars of modern physics that stubbornly resist unification. Quantum theory insists that information cannot be destroyed. Every state evolves deterministically, preserving a cosmic ledger of cause and effect. General relativity, however, paints black holes as insatiable sinks where matter, and by extension, information, is irretrievably lost behind an event horizon. Reconciling these opposing narratives has become one of the most profound challenges in theoretical physics. To grasp the paradox's depth, one must consider what information represents in this context. It is not mere data, but the fundamental description of a system's quantum state, its fingerprint, that distinguishes one. Arrangement of particles from another. When an object falls into a black hole, classical intuition suggests its unique characteristics dissolve into singularity's unknowable depths. Yet quantum principles demand that this uniqueness persist somewhere. Several groundbreaking proposals have emerged to resolve this tension. Among them is the holographic principle, a revolutionary idea positing that all information contained within a volume of space can be represented on its boundary surface. Applied to black holes, this implies that information swallowed by the abyss is not lost inside, but encoded on the event horizon itself, much like a three-dimensional image projected onto a two-dimensional screen. This surface acts as a cosmic ledger, preserving histories and details with astonishing fidelity. Such a perspective transforms black holes from destructive voids into intricate archives, repositories where time's flow slows so dramatically that moments are stretched and recorded with exquisite detail. The event horizon becomes not merely a point of no return, but a dynamic tapestry weaving together past and present in a dialogue across deep time. Yet this notion invites further questions. How is this encoding realized physically? Can information ever escape or be retrieved? Hawking radiation, a faint thermal glow emitted by black holes due to quantum effects near their horizons, offers tantalizing clues. Initially thought to carry no information and thus sealing data's fate in oblivion, more recent insights suggest subtle correlations within this radiation might leak encoded messages back into the universe over vast timescales. If true, such leakage would preserve unitarity, the quantum principle that evolution is reversible, and uphold the sanctity of information even amidst gravitational collapse. Black holes would then function as complex communication devices, their seemingly silent consumption masking ongoing exchanges woven into space-time's fabric. This framework resonates deeply with Earth's own geological record, a layered archive where sedimentary strata capture snapshots of epochs long vanished beneath erosion and tectonic upheaval. Analogously, black holes may hold cosmic strata-encoded patterns preserved at horizons that trace history's inaccessible through ordinary observation. Moreover, these ideas ripple outward into philosophical realms. If information persists beyond apparent destruction, what does that imply about memory and identity on universal scales? Could remnants of ancient civilizations or fundamental physical processes be immortalized in these cosmic ledgers? Might our own existence be etched faintly upon horizons far away, enduring beyond our temporal confines? The interplay between black holes and information thus embodies a profound dialogue, one bridging physics and metaphysics, science and philosophy, past epochs with future possibilities. It challenges humanity to rethink permanence, not as static endurance, but as dynamic transformation across dimensions of space and time. In contemplating this paradox, one also confronts humility before nature's subtlety, a recognition that what appears lost may persist, hidden beneath layers of complexity, that reality's deepest secrets often reside where our intuition falters, that knowledge itself unfolds in echoes stretching across deep time's vast ocean. The ongoing quest to unravel this mystery propels cutting-edge research, from string theory's multidimensional frameworks hinting at holographic universes to experiments probing gravitational waves, carrying whispers from black hole mergers billions of years distant. Each advance nudges us closer to understanding how information dances at gravity's threshold. Ultimately, embracing this enigma enriches our cosmic perspective, not only expanding scientific horizons but inviting reflection on existence's fragile yet resilient nature amid an ever-changing universe. Black holes emerge not simply as endpoints, but as gateways, portals preserving stories woven into space-time itself. 11. The twisted tapestry of time. Could information persist through temporal warping? If time near a black hole bends and twists under gravity's immense grip, stretching moments into eternities or folding epochs upon themselves, then perhaps information too endures within these distortions in forms beyond current comprehension. This speculative notion invites us to envision time not as a linear river, but as an intricate tapestry woven with loops, folds, and hidden corridors where memories may linger indefinitely. Consider the possibility that temporal warping near event horizons does more than slow clocks. It reshapes how events relate, causally across scales unimaginable in everyday experience. Moments stretched toward infinity may overlap with others folded back upon themselves, creating domains where past and future blur, intertwine, or coexist in superposed states. In such realms, information might be preserved through non-traditional mechanisms, encoded not solely spatially on surfaces, but temporally across warped dimensions where chronology loses its usual meaning. This could manifest as echoes reverberating through space-time folds, patterns inscribed in gravitational waves, or subtle fluctuations within Hawking radiation, offering glimpses into histories otherwise erased by entropy or collapse. These ideas challenge conventional causality, yet align intriguingly with quantum phenomena like entanglement, where particles remain correlated instantaneously over vast distances, or superposition, where states exist simultaneously until observed. Perhaps deep time itself incorporates analogous principles at macroscopic scales near gravitational extremes. Philosophically, such temporal persistence reframes existence itself. If information survives beyond linear progression embedded within twisted timelines, it suggests reality encompasses multiple layers or dimensions where memory and history persist dynamically rather than statically archived. This vision evokes profound humility. Our lived experience captures but slivers of a richer temporal landscape. Civilizations rise and fall within fleeting intervals, while underlying patterns echo eternally beneath surface appearances. Knowledge is both ephemeral and enduring through complex interplay between space, time, and gravity. Moreover, contemplating such persistence invites reflection on Earth's own ancient past, a history partially lost beneath shifting continents and eroding mountains, yet perhaps mirrored metaphorically by these cosmic archives where moments freeze amid unfolding eternity. Scientific exploration continues probing these frontiers through theory and observation alike. Advances in quantum gravity aim to reconcile how space-time geometry accommodates such complexity. Gravitational wave astronomy uncovers signals bearing imprints from extreme events shaped by temporal distortions. Holographic dualities offer mathematical frameworks linking boundary encodings with bulk realities warped by gravity, though definitive answers remain elusive. Embracing this speculative vista enriches our appreciation for deep time as multidimensional, not merely vast stretches measured by calendars, but dynamic realms shaped by curvature and quantum subtlety, where pasts intertwine with futures beyond immediate grasp. 12. Philosophical reflections. What black holes teach us about time, memory, and existence. Beyond equations and observations lies a deeper resonance, a philosophical meditation stirred by black holes. Enigmatic dance with time and information. They compel us to confront questions fundamental to human understanding. What is time? How do we remember? What does it mean to exist amid forces indifferent to life, yet intricately linked to our perception? Black holes reveal time as fluid, a dimension mutable under gravity's sway rather than absolute flow, marching uniformly onward. This challenges everyday intuitions rooted in steady rhythms measured by clocks or seasons. It invites recognition that now is local and contingent, a fragile construct shaped by vantage point within space-time's curvature. Memory, too, emerges as more than biological storage. It becomes entwined with physical processes governing information preservation. Amid entropy's relentless advance, if black holes encode histories on horizons or stretch moments infinitely through dilation, then memory transcends individuals or civilizations. It pervades cosmos itself as patterns inscribed within reality's fabric. Existence gains layered meaning through this lens. Transient lives flicker briefly against deep time, yet contribute threads woven into grander tapestries spanning eons. Fleeting moments resonate eternally within cosmic archives hidden beyond ordinary sight. Destruction coexists with preservation in cycles, shaping stars, galaxies, and perhaps consciousness itself. These reflections evoke awe tinged with melancholy, a recognition both of human smallness amid vastness and enduring connection. Through shared participation in universal rhythms, they inspire humility before mysteries, vast yet inviting exploration, wonder at nature's capacity for paradox blending, annihilation with continuity, courage to seek meaning amid uncertainty inherent in existence unfolding beneath stars' eternal gaze. Furthermore, black holes stand as metaphors for thresholds faced throughout life, the boundaries between known and unknown, between presence and absence, between past remembered and future anticipated. They symbolize transition points where perception shifts profoundly, where understanding deepens through grappling with limits, where curiosity propels forward despite uncertainty. In embracing these lessons, humanity affirms its place within cosmos, not merely as passive observers but active seekers weaving knowledge from fragments glimpsed beyond horizons where time nearly halts, a testament to resilience amidst impermanence. Conclusion. Embracing mystery within deep time's vast ocean. As we conclude this exploration into black holes' role connecting information and deep time, a journey spanning paradoxes at event horizons through twisted tapestries of temporal persistence, we find ourselves humbled yet inspired. These cosmic enigmas remind us that while much remains unknown, singularities defy comprehension. Holographic encodings challenge intuition. Temporal warping bends reality. The pursuit itself enriches understanding profoundly. Black holes emerge not solely as destructive voids devouring matter, but as profound interlocutors in universe's narrative. Archivists preserving echoes across epochs, bridges linking disparate realms of space-time, mirrors reflecting humanity's quest for meaning amid infinite complexity. They invite us to embrace uncertainty with reverence, to recognize knowledge grows through dialogue between observation and imagination, between physics' rigor and philosophy's depth, between fleeting moments experienced here below and eternal currents flowing far beyond sight. Within their shadowy embrace lies hope that despite vast distances separating stars or epochs dividing civilizations lost beneath, Earth's mantle information endures, connection persists, existence asserts itself dynamically across dimensions intertwined by gravity's silent hand. Thus stands the paradoxical legacy of black holes. Gateways forged from stellar death, yet portals illuminating paths toward deeper insight into reality's timeless dance. A dance, inviting all who dare look upward to join ongoing conversation written across cosmos's endless canvas woven from space, time, matter, and memory itself. 11. The non-absolute nature of time, a cosmic reminder from black holes' time, as perceived by human senses, is a steady, unyielding river flowing from the past into the future. It is measured by the ticking of clocks, the cycles of seasons, and the succession of generations. Yet, this intuitive sense of time's uniformity is but a fragile construct, an artifact of our limited vantage point within the vast cosmic arena. Black holes, those enigmatic abysses sculpted by gravity's relentless hand, stand as profound reminders that time is far from absolute. They reveal that what we call now is but a fleeting slice in a continuum where moments stretch, contract, and sometimes even overlap in ways that defy ordinary understanding. Imagine two observers, one stationed safely far from a black hole, gazing into its depths, the other daring to approach its event horizon, the boundary beyond which escape becomes impossible. For the distant observer, time near the horizon appears to slow dramatically. Clocks carried by the approaching traveler seem to tick ever more slowly, their hands crawling forward with agonizing lethargy. Moments that for the traveler pass normally are stretched into years or millennia when viewed from afar. This divergence encapsulates a fundamental truth. Time is relative, its passage contingent on position within space-time's warped geometry. This relativity shatters notions of a universal present moment. The now, experienced by one observer, may be vastly different for another, a concept alien to everyday experience but central to Einstein's theory of general relativity. The black hole's immense gravity warps not only space, but time itself, bending it like light through a lens and distorting temporal flow as profoundly as spatial dimensions. The implications ripple outward beyond physics into philosophy and human self-understanding. If now is local and contingent rather than global and fixed, then history and future are not monolithic constructs but layered tapestries woven from myriad perspectives. Time becomes a multi-dimensional fabric where events once thought sequential may coexist or fold upon themselves. This insight invites humility before deep time, the vast expanse spanning billions of years before humanity's brief flicker and stretching infinitely beyond our present moment. Our lived experience occupies but an ephemeral thread in this cosmic weave, yet black holes remind us that even this thread can be stretched or compressed by forces far beyond mortal scale. Moreover, this relativistic nature of time challenges our grasp on causality and memory. Events near a black hole's horizon may linger indefinitely when observed externally, yet unfold swiftly internally. Such temporal dilation suggests that information, histories, memories, physical states can persist in forms inaccessible to ordinary perception, encoded within space-time distortions. Could this phenomenon offer clues about Earth's own ancient past? The planet harbors layers of geological and fossil records, a sedimentary archive chronicling epochs erased or obscured by erosion and tectonic upheaval. Similarly, might black holes act as cosmic archives, preserving moments stretched beyond ordinary flow? Could they hold echoes of civilizations lost beneath deep time's relentless tides, fragments suspended within warped temporal domains? These questions bridge science with speculation, physics with philosophy. They beckon us to consider time not as a linear arrow, but as an ocean with hidden currents, eddies where past and future mingle, vortices where moments freeze or swirl back upon themselves. In contemplating these enigmas, one confronts both awe and existential vulnerability. The certainty with which humans cling to temporal continuity dissolves amid space-time's curvature, identity anchored in linear. Memory must reckon with multiplicity of nows. Yet within this uncertainty lies profound beauty, a universe where time itself dances fluidly, where endings birth beginnings, where existence unfolds across dimensions both seen and unseen. Black holes thus serve as cosmic teachers, silent sentinels reminding us that time is mutable, that our present is but a transient vantage point framed by gravity's hand, that deep time stretches far beyond human reckoning. 12. Conclusion. The doorway between nothingness and eternity, at journey's end, stands the black hole, not merely as an object, but as an emblem of paradox, simultaneously a door to oblivion and a gateway to infinity. It marks the threshold between known physics and mysteries yet uncharted, between destruction's finality and creation's eternal dance. The event horizon, the veil shrouding the singularity, symbolizes limits, both literal and metaphorical. It is the boundary where light dies yet questions ignite, where our grasp falters yet imagination soars. Crossing this frontier means surrendering to forces beyond comprehension, but also glimpsing realms where time bends toward eternity. Within this domain lies the profound lesson that existence itself defies simplistic narratives. Life flickers briefly against deep time's vast ocean. Civilizations rise and fall beneath stars in different gaze. Matter collapses into points of infinite density, while space-time stretches moments into forever. Yet black holes teach resilience amid impermanence. that endings are thresholds, that nothingness harbors potential, that destruction entwines with preservation in cosmic symphony. They invite reflection on humanity's place, not as masters but participants within universe's unfolding story, not as isolated beings, but threads woven into space-time's grand tapestry. In embracing these truths, we find humility tempered by wonder, uncertainty balanced by curiosity, smallness suffused with significance. The doorway between nothingness and eternity remains open, a silent call to explore deeper mysteries, to seek meaning amid enigma, to acknowledge that in the heart of darkness lies light, the light of understanding stretched across infinite horizons. Thus concludes this meditation on black holes' role within deep time, a testament to nature's complexity, a mirror reflecting humanity's quest for knowledge amid vast unknowns, an invitation to journey onward through cosmos's eternal dance of space, time, matter, and memory itself. 12. The abyss as a time machine, where time almost stops and humanity finds its fragility. In the vast cosmic expanse, black holes stand as paradoxes, abysses that both consume and preserve, destroy and reveal. They are nature's most enigmatic time machines, where the relentless flow of time bends, stretches, and nearly halts. Near these gravitational titans, time does not simply slow, it approaches a standstill, transforming the very fabric of reality into a liminal realm where moments expand infinitely and existence itself is laid bare in its delicate fragility. To grasp this profound truth, one must first relinquish the comforting illusion of time as an unyielding river flowing uniformly from past to future. Instead, imagine time as a pliable dimension, one that warps under gravity's might like light bending through a prism. Near a black hole's event horizon, the invisible boundary marking the point of no return, time dilates so dramatically that seconds can stretch into millennia for distant observers. For an object teetering on this edge, the universe beyond rushes forward with relentless pace, while their own experience lingers in a suspended now, caught in an eternal moment. This cosmic suspension is more than a scientific curiosity. It is a mirror reflecting humanity's place within deep time. Standing at this threshold, metaphorically or conceptually, invites an acute awareness of our own fragility against the boundless backdrop of the universe. The black hole's gravitational grip unmasks the tenuous thread by which life clings to existence, revealing how fleeting and fragile our presence truly is amid epochs stretching billions of years. Consider the imagery. An observer watching from afar sees matter approaching the event horizon, slow, inexorably, fading into red hues before vanishing from sight, a ghostly tableau frozen at the edge of eternity. Yet for the infalling matter itself, time flows naturally. Moments pass as they always do until crossing irrevocably into darkness. This duality embodies the profound strangeness woven into space-time's fabric, a dance between perspectives where now becomes relative, and the linear narrative of time fractures into layered realities. At this juncture, where time almost stops, humanity glimpses not only physical laws, but philosophical depths. The relentless march of seconds that define our lives contrasts starkly with epochs condensed into single instants near these cosmic abysses. It prompts reflection on mortality, not merely individual but collective, the rise and fall of civilizations whose histories are but whispers lost beneath Earth's geological mantle. Yet within this contemplation lies hope. The black hole's edge is not solely a symbol of annihilation, but also one of preservation, a natural chronometer where moments accumulate like sediment layers in a cosmic archive. Just as Earth's strata bear witness to eons erased by erosion and upheaval, so too might black holes encode history stretched beyond ordinary flow, fragments suspended within warped temporal domains. Moreover, these realms challenge us to rethink memory itself. If information endures at horizons where time dilates infinitely, then memory transcends biology and culture. It becomes inscribed within space-time geometry, a universal ledger preserving existence across deep time's ocean. In this light, black holes stand as archivists of cosmic memory, their event horizons shimmering with echoes of past events frozen in time. The implications ripple further into existential inquiry. When time nearly halts at these boundaries, notions of past and future blur, causality frays, identity wavers between fleeting presence and eternal suspension. Such paradoxes invite humility before nature's grandeur, a recognition that human understanding captures but slivers of reality's vast tapestry. Yet even as black holes embody ultimate limits, the singularity where physics collapses, they also beckon toward new frontiers of knowledge. They compel us to explore beyond horizons visible only through imagination fused with scientific endeavor, to embrace uncertainty, not as defeat, but as invitation, to find meaning amid enigma. In essence, standing at the brink where time almost stops is to confront humanity's smallness and resilience simultaneously, to see ourselves as transient sparks flickering briefly, yet contributing threads woven into space-time's grand design. It is here that deep time reveals its true nature, not merely an endless succession, but a multidimensional ocean where moments stretch into eternity and existence unfolds across dimensions intertwined by gravity's silent hand. Thus, black holes remain profound teachers, silent sentinels illuminating the doorway between nothingness and infinity, gateways inviting us to journey deeper into understanding life's fragile beauty within cosmos's eternal dance of space, time, matter, and memory itself. In their shadowy embrace lies both mystery and revelation, a reminder that while we may be small in scale and fleeting in duration, our quest for meaning endures across epochs, echoing through horizons where even time itself almost ceases to be. And so ends this meditation on black holes as nature's ultimate time machines, a testament to wonder born from paradox, a call to explore beyond limits known, an affirmation that within destruction dwells preservation, within endings lie beginnings, and within deep time's vast ocean flows the eternal rhythm, inviting all who dare to look upward towards stars' eternal gaze.